All right, welcome to my talk about RxFireDroid. Basically, it is a journey from the idea of a library or an open source project until it is available in MavenCentral or jCenter. So for everyone who came here because there's an Rx in the title and wants to learn about Rx, this is the wrong talk, because I'm not going to talk about Rx. I'm going to talk about the process from getting a library to MavenCentral. So just one quick slide about myself. I'm a freelance Android developer from Germany. I have a lot of stuff on my GitHub repository, like from my previous talks, and also everything that you will find in this talk is also available on my GitHub profile. I have the links on the last slide later, and I will also share the slides, don't worry. And also I'm a lead of the GDG Bodensee, it's a German word, group. Who knows about the GDG groups? It's the abbreviation for Google Developer Groups. Those of you who don't know about it, there is also a GDG Torino. They have their stand right around this corner there, I think. Go check them out. It's basically a community for developers all around technology. They do frequent tech talks, meetups, whatever. It's really worth checking it out. All right, so let's get started with the idea itself. Most important stuff. What are the requirements for your idea to be worth sharing with people? First of all, it has to be of public interest. If this is some project that only you will ever use and nobody else will be interested in it, it doesn't make sense to go all of that journey that I will now present you, because nobody will credit you for your work or whatever. So the second point is do something that's not already there. So don't do the fifth library for the same thing. It only makes sense if you contribute something that hasn't been there before and that helps people. Also, you might be able to do it better than the other five. Then it makes sense. You might be only the sixth, but in the end, you might be the only one that people are using because yours is the best library of those six. And the last point is it should be more than a pull request to another project. We will come later more on the detail on pull requests and stuff. Just now, for now, imagine it as a contribution to another project that's a pull request. And if your contribution is only just an addition to an existing project, then only add it to the existing project. It doesn't make sense to create a whole new project with a whole new community around it and everything if you just add a tiny, tiny bit to an already big existing project. That wouldn't make sense. So what kind of ideas can be successful in being an open source library? The first type is you have an existing private project that only you are using so far, and then you learn that maybe you need it in a second project. You have already coded it and you copy paste it because, yeah, well, it's only two projects, not going to be of any use in any other project, and then you realize, yeah, it's getting more and more projects that you have to copy and paste the code. So yeah, might be worth making a library out of it. And if you realize that not only you will be using that library, but maybe it's useful to others too, yeah, it makes sense to make it public and available to others. The other thing is a really new open source idea. If you came up with something that hasn't been done before or a new technology, it totally makes sense to be the first person who creates a library for that. People will be really thankful. Other than that, it happens that there are awesome libraries that are really, really successful, but all of a sudden the developer chooses to not maintain it anymore, to not make new features, to not fix issues, whatever, for whatever the reasons might be. And he also don't want to give the project to somebody else, then yeah, it's stuck. So then it makes sense to create a new project that is maintained and that you maintain and that creates, maybe you can get the community from the other project moving to your project. So then it makes sense. A little bit more detail on those three types again, because this is really the essence. You have to have an idea that is worth investing all that work. So first of all, it's code you have already written. Some code is needed in another project, like I explained. You have to copy paste it, and others might be interested in that code. That is for your private projects. The open source idea might be something that doesn't exist yet, or a library for a whole new language. Kotlin was emerging, there was no library, so yeah, people of course created libraries for Kotlin. And it might be the same as with all the other new emerging languages. For example, yesterday we had a talk about Fuddler, I think, yeah. Obviously, it's really new. There are not many libraries out there, so go create your own. Or simply do an add-on to an existing one. And the third scenario was the fork, of course. We have to port another project maybe to a new platform. Maybe let's take native Android libraries. They were done for ARM v7, whatever, and then all of a sudden there were x86. Yeah, maybe just do a fork of an existing project and do the x86 version of it. Or, as I said, revive an abandoned project. So, what's next in the journey to MavenCentral? You have an idea, you're going to write code, you're having to manage assets and everything, so you will need version control. So why do we need it? Maybe we need to collaborate with people. So maybe not only you are working on that project, but multiple people. So version controlling systems help you to make this collaboration easier. Of course, version control systems provide you with versioning for files. You can go back in history and stuff and restore older versions if you did a mistake or whatever. It also is, you can think of it a bit of a backup. So also you can keep easily track of the versioning history. You can step back in history. You have branches that you can emerge from, etc., etc. And all of the versioning tools provide you with an easy way to compare versions of your files. So what changed since the last time I edited this file, etc., etc. There are mainly two types of versioning tools that you can use. There's the client and server model, and there's a distributed model. The client and server model has one central copy of your repository, of your project, and it is stored on the server. So on your client, on your workstation, you only have a copy of that repository, the version that you are working on. And if you're finished, you just commit to those backend server and he manages the history. If you're going to grab a previous version from the history, it downloads it to your PC, that's it, you can work on it, and then you can commit it back to the server. But only the server knows about the history most of the time. So it heavily relies on network connection, of course. You can work on your local copy in offline mode, no problem, but you cannot push stuff back to the server if you don't have a connection. So that's a big issue of client and server-based systems. On the other hand, we have distributed systems. So here, every client possesses a full history of the whole repository. It's fully independent from all of the other participants in the system, and all of them offer the option to sync with the other repository copies. So basically you can still have a main server that has all the stuff on it, but if you check out a copy on your laptop, you also have a full copy of it. So what are the alternatives? Coming way back in history, there was CVS, which was client and server. It was free, but it's not it is still maintained, it gets security fixes and stuff, but there are not going to be any new features implemented. Next, there was Subversion. Some still use Subversion. It's also client and server, it's free, and it's from Apache. Then there is Mercurial and Git. Both are distributed systems, and both are free. The most commonly used one now is Git, like in GitHub, GitLab, whatever, all of those use Git. Although some of them also provide the opportunity to use other systems than Git. But Git is the most commonly used. That's why I will be only in the future of the talk be talking about Git. So there are some real basic commands for Git here. First of all, you have to init a folder to be a Git repository. Then it creates some metadata so that it can manage the history and stuff. Then you have to add files to the repository. You're going to edit those files, save the changes, etc., etc. And when you're done, you commit the changes to the repository. And it will be managed. All right, so much for our version controlling systems. The IDE integration is present in most of the modern IDEs. So for example, this is from Android Studio. You know, there is the version control tab here at the bottom, and it gets you like diffs on your local changes. You can browse the history of your Git repository and everything. It's all there. You don't need to worry about command line commands. No? All right. Okay, when you've chosen a versioning system, well, the next step is you have to host it somewhere. If you chose obviously if you chose a client-server solution, but also if you chose a distributed solution, it doesn't make sense really to only work on your laptop, but you want to have a backup, etc., etc. And also if you collaborate, there are multiple versions of the repository on the laptops of the developers, so you might want to have a central point that is on a server somewhere, on a hosted service. So why? You want to have a backup anytime, and those hosted services, they also create backups of your repository, etc., etc. You don't have to worry about server maintenance. That's a big plus. So they also offer advanced features for collaborations, like pull requests. We come to those later. You can sit back and chill and don't worry about server maintenance, security patches, version updates, whatever. They do all of it for you. And most of them also provide tools for automating stuff, like continuous integration, continuous delivery. I'm going to go into more details later here. So what are the most important alternatives here? It's GitHub. GitHub is free for public repositories. So if you're going to do an open source library, GitHub is fine. You're all good. But if you want to do it for work, for example, and your repository should be private, you have to pay. So then next there is GitLab. It's pretty similar to GitHub, but it's not from GitHub, it's from the GitLab company. And it's all free. So you have unlimited public repositories, unlimited private repositories. Of course, you have some quota on disk space, but it's way enough. And it's totally free. There is a hosted solution that you host at GitLab. They host it for you, or you can download that so-called community edition that you can host on your own server if you like. Next, there is also Bitbucket. It is free also for private repositories. Also, it has a limitation on the number of team members that can work on your project. I guess it's 5 in the free version. So if you have a bigger team, you have to pay. All right, handling with those remote copies. There are some new commands for Git that you might want to know. First of all, you have to get the copy from the server to your laptop somehow. And this is the git clone command, just with the URL of the repository. In my example, the library that I created. So if you want to pull updates from the remote, command is pull, obviously. And origin is also always the standard server address. It's an alias. And if you have made local changes, you can push them to the remote with the push command. Pretty straightforward. So for my library, I chose GitHub as hosting service. So let's get a little bit more into detail for GitHub, which is the most used hoster for open source projects. It has some really neat features, like it hosts your code, obviously. It has an issue tracker integrated. You can do pull requests, more details later. You get really nice statistics on how you commit stuff to your project, at which time, which team members commit when, and what are the most used languages in your project. A lot of statistics. Next, you have a wiki integration that you can use. You have collaboration features. You can manage a team of users. You can provide roles and permissions and everything. Pretty nice is webhooks or integrations. You can integrate with continuous integration servers, with mail services, sending you mails on changes, or with chat systems, whatever. And also pretty neat is GitHub Pages. Pages lets you host static content on GitHub's servers. Like, you know, those static generated sites like Jekyll can create a whole block out of static pages with only HTML and CSS and JavaScript. Those can be hosted fully at GitHub Pages, for example. All right. Pull requests, pretty important stuff. What is it? Think of it as a comparison of what you changed in comparison to what is already there on the remote server. So you can commit those changes and ask the original developer of that project to it's called merging, to merge your changes into the actual project. So before doing so, of course, you don't want to just blindly merge stuff from people you don't know into your own project. You can discuss changes. You can make comments. You can commit updates after the comments, etc., etc. Or the pull request can even be rejected by the original developer if he doesn't think it's any worth. So it's a really easy way for you to ask people to contribute to a project and help you out if you don't have the knowledge or the time to do stuff. You can integrate third-party changes. All right, how does it work? In Git, you can create things called branches. It's just let's imagine it as a tree, and you create a branch from the normal code base that you can work on, and at a point later you can remerge that branch to your original code base. So you create that branch, you make changes to the project, you commit those changes on the branch. The normal project is not affected because you're on a branch. And then you submit those changes that you did as a pull request. Here is the pull request in this process. So then you can, the original developer can react to feedback, can comment on it, etc., etc. You can make updates, and when you're done, he selects to merge the pull request, and it's going to be in the core project. Quick screenshot of how it looks on GitHub. If you make a pull request to my RxFireDroid project, there is a list of the changes. Here's one commit in it, and you can also see details on which files changed, also the actual changes in a neat view of side-by-side comparison. That's pretty nice, and then you just say create pull request and the process starts. All right. Next, I have created the project. It's called RxFireDroid. And why did I create it? There are already many Rx wrappers for Firebase, but all of those are version 1 of Rx, and I didn't want to use version 1 since there's version 2 available. So I created an Rx wrapper for version 2 for one of my own projects, And then for a second one, like, you know the story, we had it previously. And yeah, then I thought, yeah, let's create a library on GitHub for it. All right, quick explanation on what Rx is. I'm not going to read out the quote. It's just mainly a nice tool for modeling a flow of items. You have the ability to manipulate those items during the flow. And you have pretty comfortable error handling in it, and also thread management is really nice, really nice. Okay, this is just one example of a function here. You have a map function. This is one of the manipulations during that flow. And you have items flowing down the pipe here. You have a 1, 2, and a 3. And that map operation manipulates those items. It just multiplies them by 10. So your resulting stream doesn't say 1, 2, 3. It says 10, 20, and 30. That's basically Rx in 2 slides. Okay. So how does it work for Firebase integration? For example, for the login, you just use the static method that I created with a login and a password, and then you subscribe to it. And what you get is either a success callback or an error callback with a throwable or an exception. So pretty easy to use. No need to handle with Firebase callback stuff and everything. All right, what's the big change from Rx1 to Rx2? Why did I choose to do Rx2 instead of 1? You don't have any null values in Rx Java 2 because providing a null value will raise an exception immediately. You have a much better concept of back pressure stuff. It's pretty deep in Rx already. You have single completable maybe instead of just one observable class, which makes it easier for newcomers to use the right thing. It's pretty self-explanatory. If you have nothing to emit from your flow of items, but you just want to do a background operation, then it's a completable. If it's gonna emit exactly one item, like with my login, you have a single. Pretty easy. Then there was a lot of confusion about the observable.create method in version 1, and in version 2 this is fixed. They fixed it by just writing in the documentation, sorry, there has been a lot of mystery going on about the create method in version 1 and how to use it and when not to not use it, so we fixed it by just internally now calling the correct methods for you and just renaming them to create. So, pretty nice. And they have a lot of new cool stuff for testing going on because it's important because we're getting to testing on the next slides. Here we go, testing. Next thing you want to do in your journey to MavenCentral is you don't just want to publish your stuff directly to MavenCentral. You want to test it, of course, before you publish it. So you can do unit testing. It's the most simple form of testing, and you just test specific functions on their own without any dependencies and stuff. Pretty easy. I have one function that converts stuff to lowercase with some special cases, etc., etc. And this is one test for a preceding space in one word, and so that is it's not trimmed by the function. That is the test here. So you assert that it equals space lowercase t est, and I provide lowercase space uppercase t est. And of course the desired result is this. So pretty simple test, nothing to mention here anymore. Next interesting stuff when you do libraries is instrumentation testing. This is important when you need to test stuff that depends on, for example, on the Android framework. Of course, if you do JUnit tests, you can only test simple Java functions. But maybe, in my case, we have the RxFireDroid library, Firebase stuff. Firebase is connected to Play services. So I have to have a testing environment that offers me play services. Otherwise, my functions wouldn't work. So those tests are being run on a device or an emulator that is connected to your laptop or to a continuous integration environment. And yeah, most of the time it contains multiple components that work together. There is the Android testing support library that provides neat features for it, like Android JUnit Runner or Espresso for UI testing, or UI Automator, which helps you automate UI testing. All right, this is an example from my tests. I was trying to write a test that sets a value on the Firebase backend and reads it back. So what do? I have my database class here, and I call setValue, like I read test value and I write it true. And because we're in a test, this is not going to be asynchronous or in the background thread or whatever, so we blocking wait for the result for it to complete. And after that, we have an assertion that we read the value, test value, like above, and the result has to be a true. Here. Pretty easy test, again. If you want to see more tests, just go to the GitHub repository. You can view all the tests that I have implemented. Android Studio has a pretty nice integration for testing. You just right-click on your project tests and say run the FireDroid database test. That's the class, what it's called. Or you can do the Gradle way. This is still a view from Android Studio, the Gradle view, where you have all the tasks in your Gradle project. And under the verification step, you have a lot of stuff like connected Android tests, like normal test. This one does the JUnit tests, and the connected Android test does the instrumentation tests, for example. Or if you are going to integrate it in continuous integration systems, you're going the command line way, which is also just the Gradle invocation, and you might want to have a clean build of your project. Then you build it and you run the JUnit tests and the connected Android tests or whatever tests you need to run. All right, Android Studio also provides a neat view of your test results. After running it, you see that everything is okay or that there have been errors. It also shows you what the expected output would have been and what the actual output was, etc., etc. Pretty nice. So now you have tested everything manually on your laptop. No, that's not the way we go. We use continuous integration systems. What do? They help you stop regression bugs because all of your changes will be tested, for example. It is a neutral environment. You might have some special environment variables on your local laptop or whatever, but on a continuous integration environment, it is a clean environment. Let's put it that way. You always have up-to-date statistics on your project if you gather them during that step. And yeah, it's not going to happen that you commit changes that break your project and they're going to be merged into the master of your repository, for example, because the continuous integration environment will tell you, oh, there was an error. You might want to look at it before going further. This is Jenkins, a pretty frequently used one. You host it on your own server, and it's totally free. So then there is GitLab. Like we have the hosting service, and they also offer a continuous integration called GitLab CI. It's hosted by GitLab, and it's also totally free. And there's also Travis CI, which is free for open source, like with GitHub. It was also free for public open source repositories, and this one is a CI solution, which is also free for open source. I chose Travis because its integration with GitHub is really, really nice. All you have to do is go to your project, add a .travis.yml file, configure your build, any special steps that you need to perform or whatever, And then you have to sign in at traversci.org and sync your GitHub profile, and that's it. You're all set. Now Travis will build every commit that you, not every commit, but every pull that you do, push that you do to your repository. How does it work? This is the configuration file. Let's go over it step by step. You first define what is the language of your project. This is an Android project. You define what version of the JDK you want to use. Then you have some Android-specific stuff you can configure. You can say which components does it need. Of course, it needs the platform tools and the tools to compile everything. But which version? Yeah, you can use build tools version, and then you put your version that you use in your project. It will install it. Also, what is the target SDK of your project? You can install the SDKs that you need. Additional components like the Google repository, the support repository, Google Play services, it's all there. You can just have it installed. And also emulator images. All right, so now we have configured our environment, and now we want to do the actual execution. So there is a before script and a script. There's also a post script, but I haven't used it here. So before we actually execute all the stuff, we have to do some setup. We have to create an Android emulator, Android create AVD. We have to start that emulator that we just created. We have to wait for that emulator to finally finish booting. And this is just a quick hack so that the emulator doesn't hang on a CI environment that doesn't have a display connected to it. Might cause problems. And then this is the actual script that you execute in order to build your project. So what do we do here? I have to change the directory because I'm working in a subdirectory called library. Then I have to make the Gradle shell script executable, and we execute a familiar command line that we had previously. We do a clean build of our project, we build everything, and then we test everything. Good. Next point is we have built everything, test everything. Great. So now we have to put it somewhere for others to be accessible. So that's continuous delivery. You can deliver your stuff that has been built and tested to different environments. Like you may want for an app to be put on the Play Store, on the Amazon Web Store, or whatever own store or publication mechanism you use. Or in our case, we might want to put our stuff on MavenCentral and jCenter. And there's no need for any manual interaction here. It's all automated. So alternatives, just check out the alternatives for continuous integration. All of those systems provide also abilities for continuous delivery. So one more addition to our Travis file, we have after success. What I say here is just a little check if we are on a release branch and this is not a pull request, but a real merging into the release branch. Then what do? We change the directory, of course, and we call a Gradle task here called bintray upload. So what is bintray upload? Oh, strange. First there was MavenCentral, and then later they came jCenter. And jCenter is from bintray. That's where the bintray comes from. So it's a central repository for software. It makes it really easy to integrate third-party software into your own software. It has versioning and everything, and yeah, it is really easy to provide your software to others. So how does it work? All of you knows these block in your Gradle files from your Android projects. You have dependencies, and you just integrate, for example, RxJava in version 2.1, whatever. But there is, yeah, somebody has to upload this stuff, of course. So here's how it goes. You have to build the necessary artifacts, which we did on the previous slides. Then you have to provide some metadata about your project and your files, and provide some authentication, and then you can upload your stuff. How does it work here? first you have to build your artifacts. We have to build Java docs, we have to build a sources jar, and we have to build the Java docs jar. So these are our artifacts. Unfortunately, you still have to declare all this stuff on your own. It's still not integrated somehow with a neat alias or shortcut or whatever. Yeah, pretty cumbersome. So next step was to provide metadata. So you have to provide a lot of metadata about your project. For example, what is the file that you want to publish? Where is your Java doc and your sources? What is the artifact name? What is the group name? And which version are you going to upload? And a lot of more metadata that I'm not going to go through every detail here. You have to provide the open source URL of your repository, which license is it under, who is the author, etc., etc. And then you can actually publish stuff, like we had before with the bin tray upload task. But where does it get your authentication from, etc.? This is the bin tray block in your Gradle config. So you have to provide a user and a key. Let's imagine the key as your password, kind of. Here I read it from environment variables because, of course, if you have an open source library, you don't want to put your password in the file. It doesn't make sense. Everybody would have your password. So the continuous integration environments, like, for example, Travis here, provides you with a mechanism to inject those secret stuff as environment variables, namely here bin tray user and bin tray key. So you are going to publish a Maven type project. You are not going to do a dry run. You can do a dry run which would execute everything but not actually upload stuff. Instead, you're going to publish your stuff, and you're not going to overwrite if there is also a version, already a version, the same version that already exists. You're not going to overwrite this. All right. Some more metadata about your stuff. You have, of course, state the name of your project. You have to, again, say what is the user, a description, an issue tracker, a license, everything. Just check it out in the repository. You can use it as a template for easy setting up your own project. And then you have provide information about the version. And here is the most important block. If you also want your library to appear on MavenCentral. MavenCentral has a pretty nasty sign-up mechanism where you have to create an issue in their issue tracker and then wait for some days for a human being to actually verify that this is a valid request, etc. Really strange. Also, uploading is really strange. But Bintray to the rescue, they implemented automatic sync from jCenter to MavenCentral, and this is how you enable it. You say MavenCentral sync true, you have to provide a user again and a password for your MavenCentral account, and then Bintray will take care of the upload for you. So yeah, we're done, we're running out of time. I have put all the sources in here, which is mainly my repository. All of the code that you have seen is all in there. Check it out. So last slide. We have questions. Thank you for attending my talk.